Hello everyone, and welcome back to another card game tutorial video. In this video we will go over how to connect to the server we created in the last video. If you haven't watched that yet, be sure to check it out. By the end of this video, your game will be able to connect to multiple instances of your game. For instance, if we turn our server on and we hit continue on both of these instances, you will see that it will communicate with the other instance. If you want to download these files and help support this series, be sure to check out my Patreon linked in the description below. Now, in order to connect to a server, you need to know the IP address of the server. There are 3 different IP addresses you can use when learning networking. You have your computer's IP address, your local network's IP address, and the IP address of your router. When you use your computer's IP address, only instances of your game on that computer can communicate with each other. When you use your local network IP address, instances of your game can communicate with each other as long as the games are connected to that network. Lastly, using the IP address of your router, any instance of your game can communicate with any other instance of your game as long as it is connected to the internet. For this video, we will use your computer's IP address. If you like this video and want to see more, be sure to like, comment, and subscribe. Now, before we get into this, in order to determine your computer's IP address, you can go to Google and type in "what's my IP address," and then it will print it out here. So be sure to have this ready when we decide to use it. So let's begin. The first thing we want to do is create the client object, which we will call obj client. And the first thing we're going to do is create the create event. And the first thing we want to add to our create event are the macros we will use to represent our message IDs. You want to use these macros so whenever you receive a message, the value of that macro will tell you how to break down that buffer. The next thing we want to do is create a connect variable that will store whether or not our client has connected to the server. And we're going to do that using a script call called scr_client_connect. And we're going to pass this script 2 arguments. The IP address that we got from Google, which we will input as a string, and the port. Now, this is the same port we discussed in the server video. This is the position the client connects to the server. The last thing we will do in our create event is make the object persistent, and we'll do that by setting persistent equal to true. Now let's create the client connect script. The first thing we want to do is initialize variables for the arguments we passed. So we sent the IP address at argument 0 and the port at argument 1. Next, we will create a socket using the GML function network create socket. This function will return a unique identifier that will differentiate the client from other clients at the server end. This will be used to pass messages to the server. The only thing that will need to be passed to the GML function is network socket TCP, and we are using a TCP socket because the network we created is a TCP network. And we're going to store this in a variable called socket. Next, we will set the amount of time we will wait for the client to connect to the server. This will be done by using the GML function network setConfig. In order to set this time, we need to pass the function network config connect timeout and the amount of time we want to wait. In this case, we will do 10 times the room speed. Next, we will create a new local variable called connect. We will set this variable equal to the function call network connect raw. This function will connect our client to the server, and if it fails, it will return a value less than 0. So if the variable connect equals anything greater than -0, it was successfully connected to the server. And we're going to pass it the socket, the IP address, and the port. Next, we need to create a buffer to send to the server. And we will use the same buffer variables as we did in the server project. We then want to create a DS map to store the opponent object variables. The implementation of this will be explained later in the video. Now, if the client was successfully connected, we want to send a message to the server. This message will tell the server that the client wants to be joined to a game. We will use the following code. If connect is greater than or equal to 0, we are going to send the following message. We are going to seek the start of the buffer, and then we're going to write to that buffer message join. And message join is a macro we added to our client object. And then it will send that buffer to the server and using network send raw. And this GML function needs 3 arguments passed to it: the socket of the client, the buffer, and the size of the buffer. And in order to determine the size of the buffer, we use this GML function called bufferTell. So if the client was not connected successfully, we want to begin an alarm, and this alarm will be used to print out a message to the room. Lastly, we will return the value of the local connect variable. Now let's create alarm 0. While alarm 0 is greater than -1, the client object will print out the text could not connect to server. And at the end of the alarm, we want to destroy the client object. Now, whenever the client is destroyed, we want to make sure that the client map list and socket are destroyed. In order to do this, let's create a destroy event. In the destroy event, we will add the following code. Now let's create the draw event. The only thing we'll add to this event is the following code. If alarm 0 is greater than -1, draw the text could not connect to server. Now let's create an asynchronous network event. I won't go over this in detail because I already did in the server video. Let us add the following code to this event. So whenever a message is received by the client, async load at type will equal network type data. So we're going to create this switch event. And in this switch event, we're going to have a case that says if the type is network type data, we're going to handle that message. So this is all we will need to put in this event. But we need to create this script call. And what we're going to pass to this script call is going to be the value of async load at the position of buffer. So in the script call, we're going to initialize a local variable called buffer, and we're going to set that equal to argument 0. Next, we're going to add a while statement. And in that while statement, we're going to put true. We need this condition to always be true in the event that the server is sending too many messages to the client at one time. In that event, the messages will be combined into one buffer. So we want to cycle through the buffer until we have read the whole message. So we're going to use the following code. And in order to break from the buffer, we're going to add a condition that says if bufferTell, which is the position at which we will read from the buffer, is equal to the size of the buffer we will then break from the while loop. Now that we have this, we can begin reading the buffer. The first thing we read from the buffer is the message ID. The first thing that should be written to a buffer is always a message ID. So we will read this using the following code. We're going to create a local variable called message ID, and we're going to set that equal to buffer read, and buffer read is a GML script that needs two arguments, the buffer and the amount of data we are going to read from the buffer. And in this case, our message ID will always be size 8. Next, we're going to read the client ID. So we're going to initialize another local variable called client, and we're going to read from the buffer. But instead, the size is going to be U16. And next, we want to get the opponent object. And we're going to do that by using a script called opponent get object. And we're going to pass that one argument, which will be the client ID. So before we move on, let's create the script opponent get object. We're going to create a local variable for the client ID, and then check to see if the opponent object of that client has been added to the client DS map. If it hasn't, we will add it. So if the opponent object exists, we will return it. If it doesn't, we will create the opponent object, set that object to the client map, DS map, at position client ID, then return the opponent object. And that will look like this. So if the client ID exists in the DS map, we are going to return the value of that client map at that position client ID. And if it doesn't exist, we are going to create a opponent object, and then we're going to set that opponent object variable to the position at client ID in that client map, and then we will return that opponent object variable. Now that we have that, let's go back to the client handle message script. We can now create a switch statement for the message ID. Depending on the message that is sent, we will read the buffer a certain way. For instance, we already sent the server one message, message join, and that was created in the script called client connect. So this message only sent the message ID message join. So let's add this condition to our client handle message script. So we're going to have a case for message join. And we're not going to add any code to this case, because what is going to happen with this message is the client is going to send this message to the server, and then the server is going to send the opponent that same message that will only say message join. And we want the server to send this to the opponent, because when this is being read through, it's going to go to this script called opponent get object. And the first time it receives a message, it's going to need to create the opponent object. And that's what this is doing. So once the client receives this message, it then creates the opponent object. And that's all we want this message to do. Now that we have this, let's break away and add the code to create the client object. This will be done in the main menu. So if we refer to object menu in the step event, we're going to change the conditions to step 1. And step 1 is the continue option. So what we're going to do here is we're going to add another condition here that says, and the instance does not exist of the client object and we're adding this condition because we are going to then create the client object. So we don't want to create a client object if one already exists. And then we're going to create that opponent object. And then we're going to add another condition that says if the client object variable connect is greater than or equal to 0, which means it was connected successfully, we are then going to do this code, which is play the audio of the battle intro and go to the next room. But we don't want to include closing the INI file in that condition because we want this to close no matter what. Now that we have this, we have all the code we need to connect to another player. At this current state, we would not be able to communicate to the opponent except with the join message. However, we've already pseudo created the messages needed to communicate to the opponent. We just need to modify them. We will do one for this video and the rest will be in a later video. The message we'll modify will be script message hand change. So if we find that in our message folder, you'll see we put this code. And what I'm going to do is I'm going to change this object opponent to object client and remove this comment. Now, what we're going to do here is we're going to create the buffer to send to the server. So the way we will create our buffer will look like this. So we're going to start at the beginning of the buffer, and the first thing we're going to write to it is the message ID, which is message underscore hand underscore change. And we're going to do this using a buffer size of U8. And a buffer U8 is an unsigned 8-bit integer that is a positive value between 0 and 255. Now we're using this because it's the smallest of the buffers, and this value will never exceed 255 for any of the macros we've created for our message IDs. And the next two things we're going to pass to it are going to be the hand count and the deck count. And we're also going to use that same buffer size because the hand count will never be able to exceed the deck count, and the deck count will never be able to exceed 60. So that still fits in between 0 and 255. The next thing we're going to do is we're going to write all of the card numbers in the player's hand to the buffer. And we're going to use buffer size U32. And buffer U32 is an unsigned 32-bit integer that is a positive value between 0 and 4.29 million. Now, I'm doing this because if you ever want to change the card number system to be a very large number, which you'll see in a lot of card games, you want to make sure that you can handle a value that big. And then after that, we're going to send this buffer to the server. And in order to do that, we're going to use the GLML function network send raw, and that needs 3 arguments: our socket, the buffer we want to send, and the size of that buffer. Now, if you want to know more about these buffer sizes, be sure to center select any of these values, and you'll find a chart that goes into the buffer sizes in more detail. And one thing you want to keep into consideration is that all of these sizes that you're adding to the buffer, you can just add them up. The 8 plus 8 plus 8 plus 32, however many times you add it to the buffer. If you go to your client connect script call, we created this buffer here. So when you add those buffer sizes together, they should not exceed this value. And then we want to comment out this code. And this is what is going to be computed at the opponent's end when they receive this message. So what we're going to need to do is go back up to our switch statement and add another case. And this will be message hand change. Because now we need to add the code, because whenever we receive this message, we need to update our representation of the opponent. And what that will look like is this. So with the opponent object we created here, what we're going to do is we're going to change the opponent object's hand count to the next 8 bits of the buffer, and then we're going to change the deck count to the next 8 bits of the buffer, and then we're going to set the hand of the opponent to the next 32 bits of the buffer for every hand count we just set, and then for the rest of the possible hand positions, we're going to set that equal to 0. And we're going to need to add this here so that our opponent object updates the hand properly. So now let's cut away from this project and open up our server project. So when the server receives a message, its async load at position type will equal network type data. And then in that case, we're going to send 2 arguments to script call server handle message. And those 2 arguments are going to be the client ID value and the buffer that's being sent to the server. So then in this server handle message, this is what your code should look like. What we're doing is we're initializing the socket ID and the buffer. We're going to determine the opponent, and we're going to set the opponent equal to this temp2 value so that we can use this when sending a message to the appropriate socket, which would be the opponent of the client sending the message. And then the first thing we're going to do is we're going to read the message ID from the buffer that was sent by the client. And then depending on that message ID, we're going to read that buffer a certain way. For instance, when it comes to message join, there's nothing else to read from the buffer that the client sent. So then what we're going to do is we're going to package the server buffer, and at the beginning of it, we're going to write the message ID, and then we're going to write the socket ID to that buffer. And then we're going to send that buffer to the opponent of the client that sent the message. And then for message hand change, we're going to do something different. But before we do that, let's add this macro to the server create event. and we're going to set that equal to 2. And then we're also going to create another macro called message leave, and we're going to set that equal to 11. So going back to the server handle message, when the server receives this message, it knows that it needs to read some values from the buffer. It needs to read the next 8 bits for the hand count, the next 8 bits after that for the deck count, and then it's going to begin writing the message to the opponent. It's going to seek the beginning of the buffer. It's going to write the message ID, the socket ID of the client that sent it, then the hand count, then the deck count, and then it's going to read the next 32 bits of the buffer for every hand position that was sent over. And then it's going to send that to the opponent. So now going back to our current project, we have added all of the code needed to communicate these two messages. But before we do that, there are a few things we need to do. We only want the opponent object to be created if a message has been sent from an opponent. So we're going to remove the instance create layer for that opponent object in the player object create event. And then in the step event of that player object, we're going to add a condition that will prevent these two phases from starting if an opponent does not exist. So if the opponent object doesn't exist, we're going to return out of this event. And then in that case, we want to draw a message saying that we are waiting for an opponent. So now the opponent object won't do anything, and it will let the player know that they are waiting for an opponent to connect to the server. So now let's create a zip file for this game. And in order to do that, we're going to select this create executable button. And that will give you two options. It'll give you an installation option or a zip option. I chose zip, and I made it to where the game always remembered that. So you'll have one extra step before getting here. And then we're going to name that file, and then it's going to compress everything into a zip file. And then we can unzip it. And then open up multiple instances of our game. So now if we try to connect to the server, you'll see up at the top left corner that it says cannot connect to server. And I'll actually want that to be printed in the center of the room, but I'll fix that later. But as you can see, it lets us know that it is unable to connect to the server. And that's because we haven't turned our server on. So let's do that. And now that we have our server running, we should be able to go to the next room. And as you can see, it's not drawing any cards, and it's letting me know that we're waiting for an opponent. And now if I do this with the other instance, it begins to draw the cards. As you can see, our hand changes, so we know that the two messages, message join and message hand change, works. But now I want to show you something else. So we've already created so many messages, and those messages update this opponent clone we have. So if I set a card onto the field, it's going to do this. That's because of the messages we have. We have message field set. And what that does is it changes the opponent object's values. Now, we know hand change is working because we've commented that code out, and it will only do that if this message here was received. In the opponent view, the hand has been updated properly. So if I drop War Turtle down, you'll see this hand doesn't change because we've removed that code, but this one does because this is supposed to represent this player. And if I keep removing cards, you'll see that it'll get smaller, and if I add cards, it'll get bigger. So that's all I wanted to go over in this video. If you want to be able to download these files and support this series, be sure to check out my Patreon linked in the description below. If you want to see more videos like this, be sure to like, comment, and subscribe. And I'll see you all in the next one. But before I sign off, I want to fix that printing error. So if I go to my client object and the draw event, so I'm going to change this to room width divided by 2. And this to room height divided by 2. And then if I test this while the server is off, and I try to select continue, you'll see that it will now say in the center of the room. So now that you have this, I'll see you all in the next one.